Okay, so on that handout that we saw yesterday, where we worked through our problem, there's just a couple more things I wanted to talk about. So the last thing that we looked at was graphing this function with our graphing calculator. Maybe we copied it down here just so we can look without having to move the paper around. The last thing we looked at was graphing this function with our graphing calculator. And we already knew we were going to have imaginary solutions from solving by completing the square and solving with our quadratic formula. But when we looked at our graph, we saw no x-intercepts. And since we were equal to 0, our solutions would be those x-intercepts. Since we have imaginary solutions, we talked about how we're not going to see them on the graph. So I wanted to talk about one more way that you actually could use your graphing calculator to get those solutions. So on your calculator, I'm going to pull mine up here. On your calculator, I'm going to use a calculator page. Not a graph this time, but a calculator page. And I'm going to hit the menu key and go down to algebra. And we have a polynomial tools section here. And I actually have a couple of tools to find roots of a polynomial. So I'm just going to select find roots of a polynomial. Here is where I would enter the degree. So we've got a degree of 2 for our polynomial, since it's an x squared function. If you had a degree of 3 or 17 or whatever the case may be, you would enter that here. And then I have this roots option, and right now it's on real. That's the default for find roots. If you remember from just a second ago, I had options under that, find real or find complex. So it defaults to real, but if I come down to this box, I can also select complex. Since we know ahead of time that these are going to be imaginary solutions, I'm going to select complex. If you didn't know, you could try real, and then if you didn't get anything, try complex. And then I'm going to hit OK. And then the only thing I need to type in here are the coefficients for my terms. So it gives me my, what is this, A2 and then x squared. So this first box is going to be whatever my lead coefficient is, that coefficient for x squared. For this problem, that's -2, so I'm going to type in -2. And then my A1 is for my x term, the coefficient for my x term. So in this box, I'm going to type in the coefficient for my x term, which was -8 for this problem. And then plus A0 or A0, that is my constant term, right? So that's what I'm going to put in this box. My constant term for this problem was -10, so I'm going to type in -10. And then hit enter or OK once you entered your coefficients here. Again, be careful, make sure you use the negative and not minus. And this pops up. It's asking me, do you want to find the complex polynomial roots for this polynomial equation where your variable is x? And I'm going to go ahead and hit enter. And it pops up with -2 minus I and -2 plus I. Does that look familiar? Those are those same solutions that we got. So even if I have imaginary roots, I do still have a way to check them on my calculator with this polynomial solver function. Now, if I hop back to problem number 1, I'm just going to flip this over. We saw yesterday that problem number 1 had real roots, right? We had solutions of x equals -10 and x equals -2. I can also use this solver to check real solutions. So if I want to check my solutions from number 1 that we looked at yesterday, I'm going to hit menu. I'm going to go down to algebra, polynomial tools, find roots of polynomial. Again, those are real roots versus complex roots. So if I think I'm going to have real roots, I can select this. If I think I'm supposed to have complex roots, I can select this. If I don't know, just pick that. My degree here was 2, right? We had an x squared function. And based on the work that we did, we should have real roots. So I'm going to hit OK. Now I'm going to enter my coefficients. So we had 3x squared. And then if I hit the tab key, it goes down to the next box. I know sometimes our trackpads are a little tricky. And then plus 36x. So 36 is my next coefficient. And then plus 60. So 60 was my constant term. And I'm going to hit enter. Do you want to find the roots of this polynomial where x is your variable? Yes, I do. And we get -10 and -2. Same thing we found yesterday, yeah? Okay, so one more option you have. This one, we saw yesterday we could graph and find those x-intercepts of -10 and -2 because those solutions were real. But you can also check it with that polynomial solver. And you can check complex roots with that polynomial solver as well, which is not something that you can check on your graph. Okay, so just one more option you have with your calculator. The last thing I want to talk about today, I kind of mentioned briefly yesterday, are the polynomials we see down at the bottom. This is just a reminder that some of these options don't work on every polynomial right out of the gate. So we can factor stuff that's not just a quadratic, that's not just an x-squared polynomial. We've seen plenty of x-cubed polynomials, degree 3 polynomials that we could factor either by grouping or pulling out a GCF. But quadratic formula only works on quadratics. Completing the square and square roots only works on quadratics, only works on x-squared things, right? It's not helpful to take a square root of something that's not an x-squared or a quantity squared. Graphing we could use for polynomials that are higher degree than 2. So if I had an x cubed or an x to the 5th function, I could use graphing there. Just remember your multiplicities if we've got quadratic or cubic behavior at an x-intercept, if that's what you're looking for. So graphing and factoring I can use for anything potentially, but quadratic formula and completing the square are quadratics only. Okay, it has to be degree 2 to complete the square or to use quadratic formula. So if we take a look at our last couple of examples here, I've got some polynomials that are not quadratics. So I could try to factor each of these. In that case, that's what we're going to end up being able to do with all of them. I could also potentially use graphing as a tool to solve them, but right off the bat, I cannot use quadratic formula and I cannot use completing the square. So if those are your two go-tos, you've got some work to do before you can use either of those strategies for these. If we take a look at our first example here, I have a GCF of x. So I can factor that out. And from here, you don't have to use factoring anymore, right? You can complete the square or use quadratic formula on this part. You're still going to get a 0 from here. But for this part now, this is now a quadratic. So you could complete the square with this or use quadratic formula with this. What I have seen in years past is on the solving quiz, I'll give you a problem like this and people have straight quadratic formula. You can't use quadratic formula on this. It's not a quadratic. You have to show me that you've taken out that GCF of x first, okay? For the middle example here, also not a quadratic. It's 3 terms, like every other problem that we saw in our little packet here. But my degree here is 4. So I've got to do some factoring before I can use any of those quadratic methods. So I have a GCF of 3 here that I can pull out. That would give me x to the 4th plus 5x squared minus 24. And now I can factor this. Can't use complete the square, can't use quadratic formula because it's got a degree of 4, but I could factor this. Factors of -24, that would add to 5, that would be 8, and -3. So this would factor as x squared plus 8 and x squared minus 3. Now these you could solve using square roots if you wanted to. If you wanted to bust out quadratic formula on each of these, you could. But you could finish solving these. So I can set x squared plus 8 equal to 0, move that 8 to the other side, and then take a square root. I would have some simplifying to do there. I could do the same thing with this term here. If you, again, wanted to complete the square with these instead or use quadratic formula, you could. And then for our final example, again, not a quadratic. So I'm going to have to start with something besides completing the square or quadratic formula. Since we've got 4 terms here, we could factor by grouping. I have a GCF of x squared. That would leave me with 2x minus 3. Here I have a GCF of 2. That would leave me with 2x minus 3. Remember, when you use grouping, your stuff in parentheses should always be the same. This guy, you can go ahead and set equal to 0 and solve. This guy, you can solve using square roots if you wanted, just like over here. If you really wanted to do quadratic formula, to me that seems like a lot of work for something you could solve in 2 steps with square roots, but you could do quadratic formula there. Just remember that completing the square and square roots and quadratic formula are only for things that are quadratic, okay? So if I have something that's not a quadratic, I have to start somewhere else. Once you get stuff that's a quadratic, like these factors here, then any of these methods is fine. But until you get there, you can't use quadratic formula or completing the square. Questions for me? Okay.